Let us start series solution of ordinary differential equation. So first, what is our purpose to find out the series solution of ordinary differential equation? So let us try to understand first. Suppose I have given this differential equation d2y by dx square plus, say it is 3 times dy by dx plus 2 times y equal to 0. Right. So can you tell me what is the order of this differential equation? Order of this differential equation is 2, right? As the highest order derivative is this d2y by dx square, right, which is second order derivative. So order of the differential equation is 2. What is the degree of this differential equation? The degree of this differential equation is 1 because the highest power of this term d2y by dx square is 1. Then this differential equation, given differential equation, is linear or non-linear. So this differential equation is linear, right? The definition of linear differential equation we have already seen. Next, look at the right hand side. What is the right hand side? Is 0. So whenever right hand side is 0, the differential equation is called homogeneous differential equation. So the differential equation is homogeneous. Okay, so this is only the nature of the differential equation having order 2, degree 1, linear differential equation and homogeneous. Right, so this is called order 2, degree 1, homogeneous, linear, ordinary differential equation. And you know very well how do we find the solution of this differential equation? We use the symbolic mathematics. d2y by dx square is represented by d square y plus the second term is 3 times dy plus 2 times y equal to 0. Right. Right hand side of this differential equation is 0, so the particular integral is 0. Now only we need to find out the complementary solution. So for that what we do? The auxiliary function is d square plus 3d plus 2 equal to 0. This is our auxiliary equation. We factorize this d square plus 3d plus 2. So how do we factorize? We find out two numbers for which the product is 2 and sum is 3. So the factors are d plus 2 into d plus 1 equal to 0. And therefore the values of d is minus 2 and minus 1. Right. So here we have two values, minus 2, minus 1, both are real and unequal values. They are not equal, right? So what is the solution? The complementary solution ycx is equal to, you know that how do we write? C1 into e raised to minus 2x plus C2 into e raised to minus x, where C1 and C2 are real constants. Clear? So this is the solution, C1 into e raised to minus 2x plus C2 into e raised to minus x. But our topic is series solution. Where is series here? This is the solution. Right hand side is 0, right? So the general solution yx is what? The general solution yx is equal to ycx plus ypx. Ypx is what? Particular integral. But since the right hand side is 0, the particular integral is 0, so ycx is equal to the general solution yx, and therefore the solution yx is equal to c1 e raised to minus x plus c2 e raised to, yes, c1 e raised to minus 2x plus c2 e raised to minus x. This is the solution, right? Now we know this thing. You already learned what is the Maclaurin series of e raised to x. What is the Maclaurin series of e raised to x? Is 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial and so on. Right. So the Maclaurin series of e raised to minus x is equal to, what I have to do? I shall replace x by minus x. Right. So e raised to minus x can be represented by 1 minus x plus minus x whole square is again x square minus x whole cube will be minus x cube. So this is minus x cube divided by 3 factorial minus x raised to 4. So this is x raised to 4 divided by 4 factorial. Clear. Likewise, for e raised to minus 2x, what I do? I write minus 2x in place of x. Right. So this is 1 minus 2x plus minus 2x whole square is 4x square divided by 2 factorial minus, so actually this is minus 2x whole cube, so that is minus 8x cube divided by 3 factorial and so and so. Right. Now we replace the values of e raised to minus x and e raised to minus 2x to the solution c1 e raised to minus 2x plus c2 e raised to minus x. So this is equal to, let me write c1 into 1 minus 2x plus, can I cancel out here anything? Right, I can cancel out here 2, I can cancel out here 2 again, right, and so I am writing direct here, this is 2x square, this is minus 8 divided by 3 into 2 is 4 upon 3x cube, this is c1 into plus c2 into e raised to minus x is what? 1 minus x plus x square divided by 2 minus x cube divided by 6 and so on. So now what we do? We collect the coefficients, the constant coefficient here and here, the coefficients of x and the coefficients of x square, coefficient of x cube and so on. So it will be, this is equal to the constant coefficients c1 into 1 plus c2 into 1. So it is c1 plus c2. Now the coefficient of x, here it is actually c1 into minus 2 and this side it is c2 into minus 1. So it is plus minus 2 times c1 minus c2 into x. Likewise, the coefficient of x square. So here the coefficient of x square and the coefficient of x square. So it is 2 times c1 plus c2 into x square. Same way the coefficient of x cube, which I am not writing here, and so on. Right. So now let me explain what is happening here. Our solution is c1 into e raised to minus 2x plus c2 into e raised to minus x. This is the solution yx, right, which turns into the series. This solution c1 plus c2 plus constant into x plus another constant into x square plus another constant into x cube and so on. Right. So this final solution is called power series solution of the differential equation. Why we are interested in this solution, that is important. Now see, for us we have trigonometric functions, logarithmic functions, polynomial functions, but for electronic device can understand only 4 operations: addition, multiplication, subtraction and division. It doesn't understand what is sine, what is cos, right? So all the exponential functions, trigonometric functions will be converted into an approximated polynomial, right? And those kind of relations we have already seen, that is known as Taylor series and Maclaurin series, right? So these two functions, e raised to minus 2x and e raised to minus x, are converted into the series, right? So this is what we have given the differential equation. We find out the general solution, right? Actually this is homogeneous differential equation. We find out the solution and then we have written the series, right? But in this unit we are going in reverse way, right? That is called reverse engineering. We assume random power series. Suppose you have given arbitrary power series is a solution of the given differential equation, then which series is the solution of this differential equation? That is the purpose of this unit.